Good morning. In the last lecture, we studied different examples of SHM. We studied body tied to a spring, simple pendulum, liquid in U-tube. Now, before we go to the next question, today's first question, understand this condition. Suppose if a body is floating on a liquid, a body is floating on a liquid. Suppose it is a cylinder, a vertical cylinder is floating on a liquid. Now this cylinder, if it is pressed and left, नीचे दबा के उसको छोड़ दो, what will happen? It will perform simple harmonic motion. And what will be the periodic time of that simple harmonic motion? So suppose this cylinder is floating in the liquid or in water, and suppose H, this much height of the cylinder, is inside the liquid. It is floating on the liquid, and H height of the cylinder is inside the liquid. Now suppose if it is pressed down, suppose it is pressed down by a distance x, then what will happen? When you leave it, it will start performing simple harmonic motion. So first of all, when it is floating on the liquid, when the solid is floating on the liquid, we can use law of flotation. What is that law of flotation? Weight of the solid is equal to upthrust. Remember this, know this very well, कि कोई भी सॉलिड लिक्विड पर फ्लोट हो रहा है, मतलब जितना उस सॉलिड का वेट है उतना उस पर अपथ्रस्ट एक्ट हो रहा है. Weight of the solid is equal to upthrust acting on the solid. So this cylinder is initially floating on the liquid, means weight of the cylinder is equal to upthrust. Weight of the cylinder is mg, mass of the cylinder into acceleration due to gravity, is equal to how much is the upthrust? Upthrust का फॉर्मूला है V rho G. V is volume of the liquid displaced, rho is density of the liquid, and G is acceleration due to gravity, because upthrust equal to होता है weight of liquid displaced. How much is upthrust equal to? Weight of the liquid displaced. So it is equal to V rho G. This G gets cancelled, means mass of this cylinder is V rho. V is volume of the liquid displaced. And how much volume of the liquid is displaced? Volume of the solid immersed. Solid का जितना वॉल्यूम लिक्विड के अंदर है उतना लिक्विड क्या होगा? डिस्प्लेस होगा. So V is volume of the liquid displaced, means it is equal to volume of the solid immersed. And what is volume of the solid immersed? This much. This is the volume of the solid immersed, means area of cross section into H. So mass will be V means AH into rho. Rho is density of that liquid in which it is floating. So the mass of the floating cylinder is AH rho. This is mass of the floating cylinder. Area of cross section of the cylinder. H is the height of the cylinder which is inside the liquid, and rho is density of this liquid. It is water, so density will be density of water. So this is mass of the cylinder or mass of any solid which is immersed. Now when it is slightly pressed, उसको आप प्रेस कर दो through a distance x, तो उतना एक्स्ट्रा लिक्विड डिस्प्लेस होगा, है ना. अब ये कंडीशन खत्म हुई. ओके, लॉ ऑफ फ्लोटेशन के हिसाब से द वेट ऑफ द सॉलिड इज इक्वल टू अपथ्रस्ट. बात खत्म. उसका SHM से कोई संबंध अब नहीं है. When you press it, जब उसको और प्रेस करेंगे, what will happen? Additional liquid will be displaced, and due to that additional liquid displaced, additional upthrust will act on the solid. Due to additional liquid displaced, additional upthrust will act. So the upthrust now is acting as restoring force. जो additional upthrust act हो रहा है, that is the restoring force. So restoring force is additional upthrust, which is equal to again V rho G. And what is that V? V is now additional volume of liquid displaced. Additional मतलब इसके बाद प्रेस करने के कारण V is the additional volume of liquid displaced, which will be equal to additional volume will be A into X into rho into G. This is the restoring force, and of course it will be minus because the restoring force is in the opposite direction. So now acceleration will be force upon mass, which is equal to minus ax rho g. This is the force upon mass of the solid, which is ah rho. This a gets cancelled, rho gets cancelled. So acceleration is minus gx by h. G is a constant, h is a constant, means acceleration is directly proportional to displacement, and it is in the direction opposite to displacement, means the motion is simple harmonic motion. So now the periodic time will be 2 pi upon under root acceleration per unit displacement, that is equal to 2 pi upon under root acceleration per unit displacement is g by h. So t is equal to 2 pi under root h by g. The same formula again for simple pendulum, t is equal to 2 pi under root L by G. For U-tube, t is equal to 2 pi under root H by G. And for this floating body also, t is equal to 2 pi under root H by G, whereas H is the length of the solid immersed inside the liquid. Means again, the periodic time doesn't depend upon how much you press it. कितना amplitude है, उस पर periodic time depend नहीं है. So the same formula you can use for a solid which is floating on a liquid. So the question is, a cubical body side 0.1 meter and mass 0.002 kg. A cubical body it is, its mass is given and length of the side is given. Floats in water, it is floating on water. It is pressed and then released. इसको प्रेस करके छोड़ दिया. Okay. So that it oscillates vertically. Find the time period. Time period find करना है. अभी जो हमने देखा cylinder, same it is. The time period will be 2 pi under root h by g. Whereas h is the length of the cube which is inside the liquid, which is not given. दिया हुआ नहीं है. So first you'll have to find this. How much length of that cube is inside water? The liquid is water here. For that you can use law of flotation. Weight of the cube, total weight of the cube, it is equal to upthrust, that is V rho G. Correct? This gets cancelled. M is equal to V is area, मतलब ये जो base area है, this area into H, जितना length उसका अंदर है, so V is AH rho. So H means length of the cube inside water will be M upon A rho. This value of H you can put here. So T will be equal to 2 pi under root H is M upon A rho. नीचे क्या है यहाँ पर g, that is equal to 2 pi under root mass of the cube is given, it is 0.002 kg upon area will be L into L square, and L is given to be how much? 0.1. 0.1 ka square 0.01, that is area, into rho is density of liquid. Here it is water, and density of water is 10 raised to 3, and into G you can take as 10. Correct? ये 2 डेसिमल आगे ले लो, ये 1 हो गया, ये 2 डेसिमल आगे 0.2 हुआ, so this will be 2 pi under root, this is 10 raised to 3, 10 raised to 1, that is 10 raised to 4, ऊपर गया 10 raised to -4, 0.2 into 10 raised to -4, or you can say this is 2 pi under root 20 into 10 raised to -6 चलेगा, 0.2 into 10 raised to -4 is 20 into 10 raised to -6. 20 का स्क्वायर रूट ऑब्वियसली अप्रोक्सीमेटली कितना होगा 4.5, 4 का स्क्वायर 16 है, 5 का स्क्वायर 25 है, तो 20 का क्या लेंगे हम अप्रोक्सीमेटली 4.5, सो दिस विल बी 2 pi into 20 का स्क्वायर रूट 4.5, 10 raised to -6 का स्क्वायर रूट 10 raised to -3, 4.5 into 2 9, 9 pi, 9 3s are 27, so 28 something into 10 raised to -3, or that will be 0.028, 28 into 10 raised to -3 is 0.028, or 2.8 into 10 raised to -2 second will be the periodic time. Obviously this is approximate answer, and exact answer is 0.028 seconds. So you got the exact answer. Exact calculation हमने नहीं किए, अंदाजे से approximate calculations किए हमने, but you got the exact answer, that is 0.028 seconds. The next question says, imagine a tunnel is dug along diameter of the earth. अर्थ के डायमीटर पे ऐसे टनल VR, it is dug R पार, and show that a body dropped from one end of the tunnel executes simple harmonic motion. What is the time period of this motion? So we are not going into this question because we don't need to derive it. We'll directly come to the results. इथून समजा एक ऑब्जेक्ट असा ड्रॉप केला. If you drop an object into this hole, into this tunnel, the object will move through the tunnel up to here, right? It is moving down because of gravity from center. Center वरून gravity act होते म्हणून तो खाली आला. Now when it moves further, gravity will act in this direction, so it will stop here, and then it will start moving back. So in this way, it will perform simple harmonic motion. If a tunnel is dug along the diameter and a body is dropped into it, it will perform simple harmonic motion. And without going into derivation, the periodic time of that simple harmonic motion is under root 3 pi upon rho g. Just remember this formula. T is equal to under root 3 pi by rho capital G. And you don't even have to remember this formula. For this particular condition, the periodic time of oscillation is approximately 84 minutes. कितना है 84 minutes approximately. म्हणजे त्याला खाली जाऊन परत यायला किती मिनिटं लागतील 84 minutes. Means सपोज तुम्हाला इथून टाकलं खाली तर तुम्ही 84 मिनिटात अमेरिकेला जाऊन परत नगरला येता आपल्या गावी. The time taken to reach to America and come back will be 84 minutes. So you don't have to solve this question. You have to directly remember that the periodic time of oscillation is 84 minutes. You can convert it into seconds if the option is in seconds. The simple harmonic motion that we studied up to now was linear SHM. Linear SHM, simple harmonic motion in a straight line. SHM can be angular also. Angular SHM भी हो सकता है, and there you can use the analogous quantities. जैसे linear SHM में अभी तक जो SHM हमने पढ़ा, in linear SHM we saw that F is equal to minus kx. F is the restoring force, K is the force constant, and X is displacement from the mean position. And the differential equation of SHM was m d2x by dt square plus kx is equal to 0. This is the differential equation of SHM. This is linear SHM. If it is angular SHM, then in place of force, it will be torque. Linear motion takes place due to force. Force is responsible for linear motion, and torque is responsible for angular motion. So in place of force, it will be torque. So is equal to minus. In place of force constant, it is torque constant. We call it mu. So K is force constant, mu is torque constant. And in place of X, in place of linear displacement, it will be angular displacement, that is theta. So for angular SHM, tau is equal to minus mu theta. Tau is the restoring torque, mu is torque constant, is torque per unit angle or angular displacement, and theta is the angular displacement. Similarly, this was the differential equation of linear SHM. In angular SHM, in place of mass, it will be moment of inertia. For those students, those who have not studied rotational motion, जिनका अभी तक rotational motion नहीं हुआ है classroom में, for them this will be a new thing. But those who have studied rotational motion, they know it very well. जिनका नहीं हुआ है, अभी सिर्फ इतना देख लो, बाकी आगे देखेंगे. Okay. In place of mass, it will be moment of inertia. d2x by dt square will become d2 theta by dt square. Linear displacement, angular displacement, plus in place of force constant, it will be torque constant. Theta is equal to 0. So this is differential equation of angular SHM. Similarly, for linear SHM, periodic time was 2 pi under root m by k. So the periodic time for angular SHM will be 2 pi under root m की जगह पर होगा I, mass, moment of inertia, upon k की जगह पर होगा mu. This is the periodic time of angular SHM. Angular SHM के कुछ न्यूमेरिकल्स हम आगे चल के सॉल्व करेंगे. Okay. So this was about linear SHM and angular SHM. And we solved the topic wise numericals. हमने एक एक टॉपिक के प्रॉब्लम सॉल्व किए. Formula based, energy, right? Then simple pendulum and various examples. Now let's go to some other type of numericals in SHM altogether. The potential energy of a particle oscillating along x-axis is given as U is equal to 20 plus x minus 2 square. This is the potential energy. Okay. U is in joules, x is in meter. Total mechanical energy is 36 joule. Total energy is 36 joule. Okay. State whether the motion is simple harmonic or not. ये motion simple harmonic है कि नहीं है, ये हमको find करना है. Force is minus du by dx. know this or not? You know that work is force into displacement. So force is work upon displacement. Force is work upon displacement. Work means potential energy. So force is potential energy per unit displacement. So exact formula F is equal to minus du by dx. So F will be equal to minus d by dx of u, that is 20 plus x minus 2 square, that is equal to minus derivative of 20 is 0. Derivative of x minus 2 square will be 2x minus 2. So F is equal to minus 2 into x minus 2. Let x minus 2 be equal to, suppose, capital X. X minus 2, because x is displacement, 2 is the number constant. So x minus 2 को हमने क्या बोला? Capital X. Then F is equal to minus 2x. F is equal to minus 2x. Force is directly proportional to displacement from the mean position, and it is in the direction opposite to displacement from the mean position, means the motion is simple harmonic. First answer, the motion is simple harmonic. Find the mean position. Mean position find करना है हमको. Position is x equal to 0. Capital X क्या होता है? Displacement from the mean position. Capital X equal to 0. Mean position means x equal to 0. So capital X equal to 0 means x minus 2 is equal to 0, means x is equal to 2. So the mean position of that particle is at x is equal to 2. Correct? And third question is, find the maximum kinetic energy. Total energy is kinetic plus potential. Maximum kinetic energy कहां पर होगी? Mean position पर, isn't it? Maximum kinetic energy will be at the mean position. So total energy which is given to be 36 is equal to kinetic energy maximum plus u at the mean position. This is u. Mean position x कितना है? 2. So 2 minus 2, 0. So u will be 20, means the potential energy at the mean position. Kinetic energy maximum कहां पर है? Mean position पर. तो potential energy वहां पर क्या होगी? Minimum. Potential energy minimum. X कितना? Mean position पर 2. 2 minus 2, 0, means potential energy is 20. So kinetic energy max will be equal to 36 minus 20, that is 16 joule. That will be your third answer. Now we are solving numericals of a little different type what we solved before. थोड़े से अलग type के numericals हम all together solve कर रहे हैं. We will continue solving the questions, solving these numericals in your next lecture. So have a nice time. Good day. Bye bye.